Hello everyone. In this video, we'll be solving subarray sums divisible by k. So in this question, what we have to do is that we have to find all the subarrays which are divisible by k. So let's see if an example understand the question. So we have to find all the subarrays in this question which are divisible by 5. Minus from 0 to minus 3, the sum is divisible by 5, which is 5. Minus 5 by 5, which is divisible by 5. 5 to minus 3 is also divisible by 5. 4 to 1 is also divisible by 5. So we have to count the number of subarrays and return the answer. The first approach, brute force approach, is that we will traverse the array and find all the subarrays which are divisible by. Okay. To try all the possible subarrays, it will take of n cube solution, so it will give TLE. So the better approach would be using a hash map and storing the values of the remainder of the current sum. So the concept is here, suppose if k times p plus 2 is one sum and another sum is k times q plus 2 is another sum. If we find any value, this is the sum which we find earlier and this is the current sum. If we divide it by, if we find the modulus of it with k, the modulus will be 2. So if we subtract and if we find that the modulus is encountered before, so if we subtract both the numbers, the sum will be, we will get k times p minus k times q. The both 2's will get subtracted and these two numbers are the multiple of 5, and if we subtract them we will also get multiple of 5, which will add it into our answer. So we know that the previous modulus value to the current modulus value, this subarray will be our one subarray whose sum is divisible by k. So let's see how to uh, code this solution. So we'll just create a integer n nums dot size and a map int comma int and mp and m. And we will create int answer 0 and traverse the other int plus plus, and we'll find the current sum plus equals to numbers of and okay, we'll find the mod sum modulus k. If mod equals to 0, then we just do answer plus plus, else if m dot find mod not equals to m dot, if we have find it before, so we'll just add it to our answer hello mod, and at last we'll m of mod plus plus, we'll just return the answer. Here we are storing the value of the modulus. Here we are checking if it is present previously encountered or not, and here if the current sum is properly divisible by the variable, sorry, the k element. We'll just run it. Let me just type some more here. Just submit it. Oops, giving wrong. Oh, we forget that there can be negative number also, so the modulus can be negative. If the modulus is negative, we'll just add plus k to it. This will, let's try the solution, it's working or not. Yeah, it's working. So whenever we find a negative modulus, we just add the number to, which is divisible, which divided it, and this will be the modulus of the number, negative number. So let's see if it's working. Okay, it's giving wrong also. What is giving no answer? So let's try to submit it again. Yes, working. So the time complexity of this solution is big O of n because we are traversing the array only once, and the space complexity is big O of n.